Hello, I'm Nicholas Taubert, and this is my Pushdown Automaton designed to build and calculate the best Blizzard Sorceress at any given level in Diablo II. Figuring out what to use memory stack on was quite the challenge, to be honest. I tested out several possibilities that were unrelated to my original workshop, but I knew I wasn't ready to drop the first workshop yet, and I wanted to see how the memory stack could be used to improve it. I considered using the memory to keep track of strength, as this would make the process cleaner and more reliable. However, doing so wouldn't fulfill the novelty requirement, as my pushdown automata would have looked identical to my finite automata if I went that route. I also considered limiting the machine to only accept inputs that would represent a character without cheating. However, this would require much more than one memory stack. Not only does each skill have a max of 20 ranks, but also that maximum is not immediately 20 as soon as it is unlocked. Rather, it has a max of X, where X is the number of times the character is leveled up since the skill has been unlocked, and X is less than or equal to 20. Additionally, I really like having the reliability to be able to handle these erroneous or illegal situations. So it's just a complicated mess. The answer actually slapped me across the face before I noticed it. One of the alternatives I made and very close to almost submitted was a pushdown automaton calculator, which would take each button as a state, 1 through 9, and each operator button. Then once you press the equals button, it would work backwards to the stack to compute whatever the user input. Then I realized that's exactly what my first workshop needs, a damage calculator. Based on the skills and attributes allocated, it would then automatically prepare the calculation for the damage done per second by the primary spell, Blizzard. I later also added a health calculator, as health is a very important piece of character builds. To refresh the basics from my first workshop, it was a machine designed to automatically figure out the best character build for a Blizzard Sorceress in Diablo II at any given level by means of allocating skills and attributes. Because the Blizzard Sorceress optimal skill progression is relatively linear past level 18, this is modeled by a state to determine if the player can take the prerequisite skills, which does so by checking if teleport can be obtained, a level 18 spell, then takes the remaining prereq skills. If it succeeds, then the rest of the machine is composed of states that represent attempting to put a point into a certain skill. If the machine succeeds in doing so, it returns to that state to try to put another point into that skill. If it fails, it moves on to the next state to try to put a point into that skill, in the next skill. Once it runs out of points, the machine moves on to QSTR, where points are put into strength until the player can equip all the gear in their inventory. Finally, any remaining points are put into vitality at the self-looping QVIT. Then the machine closes and returns control to the player. Notably, the route is decently similar even if the player's character is below level 18. The primary difference is that the prerequisite skills are skipped and the machine goes straight to trying to allocate points into skills that can be taken below level 18. I go into much further detail in my first workshop video, but I will not meet the 15-minute requirement if I go any further into this workshop. So for the goals of this, it's important to note that the machine still does not account for equipped gear, so the values that are given are naked values. However, the machine is now equipped to process the skills and attributes allocated and return the calculations for the two most important numbers to the build, damage per second and health. Instead of adding the requirement for a calculator, I decided the player should only be required to have Diablo open to run the machine, not an external calculator as well. The player may want to see how the calculations work. Therefore, the machine technically does not compute the values. Instead, it prints them into the Diablo chat log here, like you can see here, and the player can then copy the message exactly to send and paste it into a web-based calculator if they choose to do so, like Google or Desmos. This also provides a workaround to provide both DPS and health to the user without the need to store either value permanently within the machine, because I can just completely put them directly into Diablo. Finally, I would like to make clear that these values are estimates. While configuring the damage calculations, I quickly ran into a difficult problem. The amount that Blizzard's base damage per second increases per level is not linear, as the amount that the damage increased per level varied throughout the table. Also, its base damage is actually a range, not a set value. Therefore, the minimum damage, maximum damage, and range between those two values increase at a slightly increasing rate that I first thought to be exponential. Additionally, the max value of a position X is often close to the min value at position X plus 2 near the beginning or X plus 1 near the end. I decided to plot these values on a Desmos graph, with the x-axis being the number of points put into Blizzard and the y-axis being the base damage of Blizzard per second. I actually had to plot 2 points per level, the minimum damage and the maximum damage. Doing so pointed out a trend to me. The graph is actually decently linear, but segmented into intervals with different slopes. The points where the slope changes dramatically are at level 8 and at level 16. I was also curious why the slope of the max and the min were slightly different, so I threw the data in a Google Sheet and noticed that the difference between the max DPS and the min DPS increases by about 1 per level, meaning the range the true value could fall on increased with the amount of points put into Blizzard. Now calculations. Blizzard does have a base damage per second plus some per level, and the amount per level depends on whether that level is between 1 and 7, a point between 8 and 15, or a point 16 and above. Our machine is not able to handle calculations with a range, so instead we use an average for each range. To be specific, between 1 and 18, adding a point to Blizzard will increase the base damage by about 18. Between 8 and 16, Blizzard's base DPS increases by about 35 per point, and any point past 16 increases base DPS by about 52. Also, we will add an additional 5% DPS for every point in Ice Bolt, Ice Blast, Glacial Spike, Cold Mastery, all the synergy spells, but that'll be seen in later stages of the project. Another huge aspect to a build is life total. So I decided to add calculating max health as an aspect of the machine. As seen in the chart, sorceresses get 40 life to start, then get another life per level up and 2 life per vitality. At first, I tried to calculate level with skill points, but it ended up being much more efficient to configure the life per level by adding it to strength and vitality. Since the character gets 5 attribute points per level up, I added 0.2 to life for every point to strength and vitality, plus the original 2 life per point vitality. Here's the whole input alphabet for the machine and what each character means. They will make more sense once you see the full Pushdown Automaton, but I will quickly go over the broad idea of them. This idea was at one point this list was at one point much longer, then another point much shorter, but this exact alphabet works as the most error-proof, sensical, specific one for this machine. The 5 after B are just as they used to be pretty much. Blizzard got its own S, and that's what the B is essentially, to account for the increase in base DPS instead of synergy work, and O now acts as an exit to more than just a skill loop. The next 5 are all new though, and mostly mirror the previous states to ensure the input string satisfies the requirements of the language. They all handle what is printed to the chat when handling when handling calculations for health and damage per second. The stack alphabet, which is entirely new, also ensures the string is input properly and uses memory to calculate the health and DPS based on the number of points put into Blizzard, its synergies, strength, and vitality. The other 2 are mostly there to make transitions smoother and divide the sections of the stack into chunks for error handling and readability. Here are the states of the machine. The left side handles putting points into the skills and attributes, and the right side handles typing those corresponding values into the chat logs so they're ready to be calculated by the user. Note that there are 16 states, QBliz1 through QBliz16, that handle calculating Blizzard's base damage because the machine essentially had to keep track of 2 numbers at once, how many points have been put into Blizzard and how many points remain to put into it. Thankfully, I was able to simply make 16 states for calculating the base damage of Blizzard and loop on the last one since all points past 16, even past 20, all increased by the base DPS, the same base DPS amount. Here's the formal definition of our language. L1 is the center that the rest of the build kind of builds around. That's the heart of it. This handles the attribute points, both their allocation and the calculation. L2 similarly smacks a string from L1 into the center of itself and throws skill allocations and calculations on its left and right, respectively. Then the final language for the machine comes from L5, which is really just a string from L3 or L4, depending on whether or not the player is above level 18 or not. The language will make a lot more sense once you see the context-free grammar. A handles the beginning stuff with prereqs. B handles Blizzard allocation and calculation. C, D, E, and F handle the synergy skills, and G and H handle the attribute points. Now, here's the Pushdown Automata for JFLAP. Here's the Pushdown Automata for JFLAP. In the calculations, there's this weird looping mechanism at QChat and QEnter. This is where we enter the values into the chat so that the machine doesn't have to remember them. QChat opens the chat log and types 40, and each state here types something into that chat log. On the top, we do the calculations for vitality and strength to find health. Then at Q enter, we send those values in the chat. We pop an O, push an O, then pop another O here as a way of hitting the Q enter state without losing track of where we are. Then we go to the bottom where we calculate the base DPS for Blizzard. And just as the original section of the workshop was structured like a loop to account for improper usage, whether the player didn't respec before using the machine, or the player used cheats to go past the default max level, or even if the player wants to add extra points past 20 to account for their gear that may add points past the capacity, there are a few fail-safes put in place for these kinds of situations. Any skills put into Blizzard past level 20 are on the same semi-linear progression that levels 16 to 20 are on. So skills can infinitely be put into Q Blizz 16, and that'll account for any of them past that. Additionally, every point into the assisting skills will provide, like the synergies, will provide an additional 5% even past their level capacity. You'll notice I removed the loop that connects Cold Mastery back to Blizzard, rendering the beginning skill allocations as no longer a large loop. This is because the calculator would not like reading inputs off the top out of order, and honestly, even in a situation above maximum level, you would still put all of your points into these skills that you could while you're there. There's no reason to return to them afterwards. Now, how do we get away with the base 40 when calculating both health and DPS? Well, 40 is actually base health, like that's the actual number, and then each state just says plus 2.2 with vitality, or plus 0.2 with strength, so that makes sense. As for DPS, the technical actual value is a range, but our machine is only capable of giving back an exact answer. So we are returning an average DPS somewhere in that range. Wonderfully enough, if we group Blizz 1 with Blizz 2 through 7, we will fall in that range by adding 17.857 to 40. Though this would otherwise be erroneous due to this meaning that Blizzard deals 40 damage with no points in it, this is solved by the escapes from each Q chat, QF, and Q synergy to either Q enter or QQ when the stack is empty. It's also worth noting that this loop between QF and Q synergy consumes S's and F's off the stack to ensure that the string was centered and follows the language and has an equal number of calculation inputs as it does allocation inputs. This is what the machine looks like implemented in C++. It's a little hard to follow, but it follows the same structure as the JFLAP representation. The only exceptions are that a vector is used to keep track of the stack, a string is used to keep track of the inputs, and a variable keeps track of which Blizzard state we are on to simplify the process. In other words, to get the whole thing to fit into one page, the states still produce the same effect, but are just summarized into a variable and a function to make the process clearer. Let me actually pull up JFLAP and code blocks real quick, especially because JFLAP was a little low resolution here for some reason. So I'm starting to run low on time, so you can use the slowdown function through YouTube if you'd like, but this is what a test string through my automaton looks like. Right here, we're going through the beginning stages where we're testing, we're putting in points into Blizzard. Now we're putting points into Ice Bolt, now Ice Blast, and then we run out of points. So we go to Strength, we start putting points into Strength, next Vitality, and now we are in the chat log and we start pasting, we start putting values into the chat that correspond to the Vitality and the Strength towards health. Then we enter it, go back to chat, and then now we're adding the values that correspond to our base DPS going through Blizzard and all the other things, and then we're done. To make it a little bit clearer, we can see in the C++ implementation, it'll actually output what we got. So this first chunk of it is what we actually put the points into, and at the bottom you can see what values would be pasted into the Diablo chat that you could copy and then paste into a calculator from there. Here are my sources from Workshop 1, and here is the citations for Workshop 2. Thanks again, guys. I wasn't able to go into quite as much detail as I would have liked, given the time restrictions, but if you liked what you saw, start this video, and I'd happily go further in depth on the aspects that I had to be vague about.